Hi there, folks. So in this video, I'm going to go over a couple of approaches to writing algorithms for programs. These are in chapter 4 in your textbook. And shown here are pseudocode over here and a flowchart over here. It doesn't really matter which approach you use as long as you are doing something like this. I tend to do more graphics. I draw pictures of things, not so much a flowchart as I do an approach like this, except especially when we get into lists, I will draw little pictures of the lists and sometimes pictures of the other data structures with lots of arrows and things. The important thing is to have a plan before you start coding. So these are very much equivalent to an outline for a paper. Let's go through the pseudocode first. Right? The idea here is to not to write a lot, to keep this as telegraphic as possible. It's just to help you understand the problem. So this is basically saying we're going to have an input that we're storing in a variable called n. We're going to have a variable called sum, which we start by setting equal to 0. So in Java, that would be int sum equals 0. A variable k that we set equal to 1. And so now at this point we have these three variables, n, which the input is supplied by the user through something like a scanner class, sum and k. And then we repeat, right? This is important, right? Repeat. This is what the chapter talks means by iteration. Those of you who know a little programming, we're talking about loops here. So repeat the following three steps while k is less than or equal to n. Right? And just to back up a bit, right? The advantage of doing these algorithms in pseudocode or flowcharts is that they allow you to focus your efforts on the problem and not the syntax of Java. You're not, or whatever language you're using. You're not worrying about the details of where semicolons go or exactly how to define something or all of that stuff related to just getting the syntax right. You're focusing on the problem itself. And once you have the problem itself well understood, the code is easy to write. Right? The compiler helps you with the syntax. The more you program, the syntax just fades into the background, just the way at this point you can write paragraphs without really thinking about the syntax because you just know it. Right? So the idea here is to focus on the problem and to understand the problem well so that when you code it, you can then just translate your solution into the particular programming language that you're using, in our case, Java. So while this k variable is less than n variable, we're going to make sq equal to k times k. So we're doing the sum of squares. That's what this algorithm is for. Then we make sum equal to the existing sum plus sq. Right? So sum is going to accumulate because each time we're adding whatever the new value of sq is to the existing value of sum. And same thing with k, except in this case we're just adding 1 to k. Right? So k is sort of keeping track of how many times we've done this. And that's why as k gets to be eventually greater than n, this loop will end and will output the sum. Okay? So over here, same thing, just using a flowchart. The parallelogram is used to indicate that there's an input or an output, so you see it here and here. Right? The boxes are used to indicate that you're just doing some basically changing variables, right? Some code where you're doing assignment statements. And then this triangle, sorry, the diamonds are used to indicate a decision point, right? And then, so there's some sort of conditional statement here, which depending upon how that, whether that evaluates the true or false, if it's true, you follow the arrow this way. If it's false, you go that way, okay? And the arrows are just used to indicate the flow of control through the algorithm, right? So we start here, we get a value from n, for n, we come down here, we set sum and k equal to their starting values. We come down here, we check that condition. If that condition is true, we continue down here, do these statements, which are exactly the same as the statements over here, right? And then we come back, here's the loop part, right? We loop back to before the condition check, and again, check the condition, and if it's true, again, we do those things in loop, and eventually, right, because we're increasing k, eventually k will be greater than n, and in that point, at that time, we go this way, and again, we have this parallelogram indicating an input or an output, and we output the sum. Okay? So this translates very easily into computer code, and yeah, I think that's all I want to say about this at this point. What approach you do, well, you know, this is great. This is also great. And you may evolve something that is some combination of these, or as I have, some variation or addition that uses these ideas, but in your own way. Okay?